Hi, men. I wanted to show you a new way to compute the phase shift. Hopefully this new method is more straightforward and easier for you. If you remember when we met the trig graphs, I said to pay special attention to what each trig graph is doing at x equals 0, because if we see that point being moved, then we know that there's been a phase shift. And so since it's all about what's supposed to happen when x equals 0, let's take, in this case, the input to the tangent function, and let's set it equal to 0. Now this method works for the sine, the cosine, as well as the tangent. We're going to take the input to each of those functions and set it equal to 0, and then let's just solve for x. So that means 2x equals minus pi over 4, and therefore x equals minus pi over 8. And so what this means now is what the tangent function should have been doing at x equals 0, it's now occurring at x equals minus pi over 8. And so that translates to a phase shift of pi over 8 units to the left, since negative pi over 8 is to the left of the origin. So that would be the phase shift for this tangent curve right there. So if you found that method a little bit more straightforward, then if you wanted to hit the pause button and try it for this equation here, y equals tangent 1/3 x minus pi, I'll show you the answer to that at the very end. Just to show you that it works for all three, let's take a look at what the phase shift would be for this equation involving the sine. Again, we'll take the input to the sine function, and let's set that equal to 0, and solve for x. So 3x equals pi over 2, x equals pi over 6. And this means that whatever the sine curve should have been doing at x equals 0, it's now doing it at pi over 6. So this corresponds to a phase shift of pi over 6 units to the right, because in this instance pi over 6 of course is to the right of the origin. So scrolling back up to that one that you were asked to try as an example, what would the phase shift be here? Well, we'll set 1/3 x minus pi equal to 0. That means 1/3 of x equals pi, and so x equals 3 pi, and this means that there is a phase shift of 3 pi units to the right. So hopefully you got that one correct. And one last thing, this works only for the tangent. If you wanted to compute the period, what you can do is take the coefficient of x, I'll circle it here in blue, take the coefficient of x and divide that into pi. The reason we're dividing that into pi is because the tangent is supposed to have a period of pi, and since there's a factor of 2 in front of the x, the new period is pi over 2. And if we were to do it for the tangent curve down here, we would take pi and divide it by 1/3, and this translates to 3 pi. So the new period here for the second tangent equation would be 3 pi. It has a phase shift of 3 pi to the right. And this graph up here, the first example I did, would have a period of pi over 2 with a phase shift of pi over 8 to the left. So hopefully that makes sense. If you have any questions, you can shoot me an email. And this works for all trig functions. All right.